The Volvo FH is a heavy truck range produced by Swedish Volvo Truck Corporation. Introduced in late 1993 as FH12 and FH16, production still continues with the second generation of FH range model lineup. FH stands for Ford Control High Entry, where numbers denominate engine capacity in litres. The FH range is one of the most successful truck series ever, having sold more than 400,000 units worldwide. In September 2012, Volvo Trucks relaunched the Volvo FH with significant technology upgrades. History: in late 1993, Volvo had unveiled its replacement for the legendary FH series in production for almost 15 years. The development of FH in what it appeared to be a clean sheet of paper design took 7 long years. The development of the all-new design 12-litre engine with its overhead camshaft and electronic unit injectors technology placed Volvo among the world's leading engine designers. First generation. There were 2 models, FH12 and FH16, which shared common cabs and chassis, and the FH12 immediately won Truck of the Year award in 1994. The 16-litre engine, gearboxes and the driveline were carried over from previous generation, albeit with many improvements and a host of additional features, including all-new Volvo engine management and its diagnostics for the D12A engine. Design and technology. Cab. The cab produced at Umeå from hot-dip galvanized, high-tensile steel allowed for greater strength at thinner panels and box sections while reducing overall weight. The new FH cab was a logical progression from, for its days, spacious but boxy F-Series cab to more aerodynamically efficient, with much improved ergonomics and much better seating unit while reducing overall weight of the cab by almost 30%. The cabin was extensively tested in a wind tunnel to confirm shape aerodynamics properties to reduce air drag, thus improving fuel efficiency. The cab featured more sharply raked windscreen, while wedge-shaped sides rounded into front panel at much wider radius corners, and the rear vision mirrors were also streamlined. The cabin was subject to the toughest cab impact test, where procedure involved placing a 15-ton static weight on the roof and 1-ton pendulum striking at the cab rear wall and at the windscreen pillars, at the end of which the cab doors must be able to be opened. In 1995, Volvo FH series became first heavy-duty truck to be fitted with the SRS airbag to further improve passive safety. D12 engine. From the design angle, the new D12A engine was one of the largest engine projects from Volvo Trucks since the 1950s at the time. The basic design was still based on direct injection inline-6 diesel engine around 12 litres displacement, but with entirely different fuel and valve systems when compared with previous Volvo engines. Built at the purpose-built facility at Scar Paragraph VDE on a fully automated line where the bulk of the engine assembly is done by robots and the final engine dressing is carried out manually. The D12A was designed as a world engine to be able to meet the latest demands in high power output, low fuel consumption and lower emissions with its single OHC design, 4 valves per cylinder and 1 centrally located electronic unit injector, integrated engine compression brake and 2-piece, steel and aluminium pistons. The engine design left the door open for future upgrades in both power output and emission technologies. VEB. The Volvo engine brake is a compression-type engine brake first introduced on D12A and since used on later designed OHC engines from 9 to 16-litre displacement. The brake operates on a principle where exhaust valve cam followers acts on secondary cam profile when engine brake is activated. Engine oil pressure is used to eliminate extra valve clearance, thus this action forces the follower against secondary lobes and unseating exhaust valves temporarily to achieve so-called compression bleeding as employed by similar systems from Jacobs, Cummins and Mack. However, Volvo's system has an extra cam lobe, thus giving 2 openings of the exhaust valves, and is designed to work in conjunction with an exhaust brake, so 2 of the engine's 4 strokes are used to raise engine braking effect, exhaust and compression strokes. Operation description: the exhaust stroke is used when exhaust brake shutter closes exhaust manifold after turbocharger opening. As a result, exhaust back pressure is raised, creating braking effect. The compression stroke is used next to utilize the back pressure in exhaust, where at the piston's bottom dead center the exhaust valve are open briefly and high pressure in exhaust manifold is then let in, acting against the piston moving upwards on its compression stroke, thus slowing it even more. Further explanation needed. Exhaust braking functions in relation to cylinder pressure, not piston speed, and increasing the engine braking effect. At the end of the compression stroke, just before piston's top dead center exhaust valves are open briefly again to release bleed compression, thus again slowing the piston on its subsequent downwards movement and consequently achieving engine braking effect, while also storing the pressure in the exhaust manifold, again using the exhaust brake shutter ready for the next repeat of the cycle. Version 98 . In conjunction with introduction of FM series in 1998, Volvo had facelifted existing FH series with minor modifications to the cab but major upgrade to the electrical system, engine and gearbox. The so-called TEA truck electronic architecture introduced a technical solution to possibility of various electronic control units to work and communicate with one another. The systems have been linked using two data buses or data links, which allowed control units to exchange relevant information over the data network. Electronics. TEA is a computerized control and monitoring system which is used to control and coordinate the various functions of the vehicle main components. The control units communicate over what is known as CAN at 2 speeds, SAEJ 1587/1708 at 9600 bits and SAEJ 1939 at 250,000 bits, where up to 8 electronic control units were used to control various functions. J1939 data link is used for mission-critical rapid communication among ECUs, and J1587/1808 is used for diagnostic and programming link as well as slow communication, for example for backup purpose. The new instrument cluster included a LCD panel to show information or diagnostic messages from the systems broadcast via J1708 data link. D12 facelift. The original D12A engine was considered as a rather conservatively power-rated, and expectations of higher power output from such an engine design was always at the mind of not only designer but customers alike. The D12C differs from earlier versions substantially, with completely redesigned engine head, timing gears and addition of bottom end of reinforcement with a stiffening subframe to cope with increased power output to 460 horsepower. Gearbox. The gearboxes were based on previous SR 1900 series and shared the same number of gears and gear change pattern. The SR 2400 series gearbox was discontinued and replaced with the now same model shared across entire FH and FM range. Torque increases from 1900 Nm to 2500 Nm were due to changes to machining of the gears as well as use of the new type of narrower synchromesh mechanism allowing increased gear width. The single control housing and the synchro mechanism reduced gear change effort by about 50%. The control housing was also identical for left and right-hand drive versions, reducing overall production cost and assembly. Version 2. In 2001, Volvo introduced the third generation of the FH and FM series with the cab and driveline given major makeover. With an investment cost of €600 million, major changes included redesign of the cab to improve aerodynamics, the new automatic gear change transmission, I-shift, new electronic system and engine improvements. New cab. The changes to the cab included a new day cab, which is 150 mm longer with redesigned air intake and flat floor. New rear view mirrors were introduced to reduce blind spots and improve airflow. New headlights and front side marker lights, new split sun visor and new wider front steps complemented the external modifications. The interior was redesigned with more rounded edges around the dashboard and new seats with integrated seat belts. Integrated telephone speaker and microphone with steering wheel controls for radio and inbuilt GSM phone were an option. As a standard equipment, FH models also included FUPS to further enhance safety by preventing smaller vehicles from being underrun, or wedged under front of the truck in an event of frontal collision. TC and I-shift. D12D's further development of venerable D12C resulted in increased power output to 500 horsepower equipped with turbo compound technology which utilized more energy from exhaust gases after the turbocharger using an extra turbine to drive the engine crankshaft via hydraulic clutch and reduction gearing. The cooling system changes coincided with more advanced electronics for engine management system with electronically controlled cooling fan which was now fully controlled by the engine ECU, and as a result fuel consumption is also reduced. I-shift transmissions is a concept of manual transmission with computerized gear change control transmission management system, TMS, which contains two ECUs, the transmission control unit and the gear selector control unit. I-shift borrowed from old transmission technologies like non-synchronized main gears which allowed a reduction in size and weight and a counter-shaft brake to achieve more precise shift control while matching engine RPM to transmission's RPM. For example, TECU requests the ECU to correct engine RPM so as to synchronize the RPM to effect a smooth gear change, similar to double declutching. 2003 FH16 intelligent power equals. After delaying introduction of new 16-litre engine for 2 years in 2003, Volvo introduced one of the most powerful trucks ever built. The D16C engine was available in two power outputs configurations, 550 horsepower and 610 horsepower, and it was a completely new design similar in the lines of D9 engine introduced a couple of years earlier for FM series. The notable design changes included timing gears being on the flywheel side of the engine, design which allows for increased airflow around the engine, more precise injection and valve operation, noise reduction and manufacturing cost due to flywheel casing being used to house timing gears as well. In 2005 Volvo had increased the available power of D16C to 660 horsepower respectively, making it one of the most powerful production truck available. Currently D16E engines are available in selective catalytic reduction at power output 580 horsepower, 640 horsepower, 700 horsepower. 2005-2008 FH equals. In 2005 Volvo introduced new design 13-litre unit D13A incorporating the same design features as its 9 and 16-litre engines and available in various power output variants from 360 horsepower, 400 horsepower, 440 horsepower, 480 horsepower to 520 horsepower. Initially available to meet Euro 3 emissions requirements, further improvements will enable the engine to meet or exceed Euro 4 and possibly Euro 5 emissions targets. D13A featured closed crankcase ventilation and also included a new type of unit injector E3 from Delphi. As a part of makeover, Volvo has also removed its naming scheme and decided to drop engine size and the model name, so the models are known from now as FH only. Volvo had also introduced on D13A engine with selective catalytic reduction an improved version of its engine compression brake, the VEB Plus, featuring additional helper rocker arm and a fourth cam lobe per cylinder. Power outputs available from 360 horsepower, 400 horsepower, 440 horsepower and 480 horsepower. In 2007 Volvo introduced D13B with exhaust gas recirculation configuration and VGT turbocharger but without exhaust particle filter, and is the only manufacturer to offer this solution thus far. The engines are available in slightly reduced power output ranging from 360 horsepower, 400 horsepower, 440 horsepower and 500 horsepower and being shared with FM series. However, 500 horsepower option is only available for FH series. 2008-2012 FH and FH16 MKII equals. In August 2008 Volvo launched an upgrade to FH series with main emphasis on a driver comfort and usability. Among features listed are windscreen wipers controlled by a rain sensor, cornering lights for better visibility when turning, powerful audio system with USB-O and MP3 inputs, as well as a swiveling passenger seat. Completely redesigned grille, steps, sun visor and headlamps combination were the most obvious visible changes over previous models. Only 6 months later Volvo once again claimed a first with the FH16 and 700 horsepower on tap, introducing one of the world's most powerful production series truck. continuing on its Euro 5 theme. Upgrades to 13-litre engines and introduction of the new 11-litre engine followed a few months later. As a part of ongoing commitment to road safety, a number of safety features were also improved, like advanced radar-controlled cruise control, driver alert system which keeps a tab on the driver's time behind the wheel with ongoing monitoring of the driver's responses, lane keeping support, LKS, which alerts the driver when crossing over the lines, and lane change support system responsible for alerting the driver when another vehicle is in the blind spot, when attempting to change lanes. In 2011, the new 750 horsepower version of the D16 was presented to the market. This engine will be delivered to customers around New Year 2012, celebrating 25 years of Volvo 16-litre truck engines. The new Volvo FH. In September 2012, Volvo Trucks relaunched the Volvo FH with major technology upgrades, a new design and more. The company also introduced the first of its Euro 6 engines, the D13K, which is available as an option on the new Volvo FH and compulsory for new trucks in Europe from January 2014. Other quotable new features is the iTorque driveline and the IC fuel-saving technology. With the new 13-litre engine, the name has changed to FH13. AEB Volvo Trucks have demonstrated the new AEB system for their FH series on YouTube. The truck did well and stopped only centimeters from the car ahead. The tractor-trailer was fully loaded to 40 tons GCW when Volvo demonstrated the system. The AEB system combines a radar and a camera that work together to identify and monitor vehicles in front. The system is designed to deal with both stationary and moving vehicles and can prevent a collision with a moving target at relative speeds of up to 70 km per hour. When the system detects a vehicle that the truck will hit at its current speed, the warning system activates a constant red light in the windscreen in order to bring the driver's attention back to the road. Gallery. References.